Hey guys, welcome to my channel Medical Pharma Education. In previous videos, we have completed the UV spectroscopy. We have not checked the UV spectroscopy. You just once check it and continue with the IR spectroscopy. In spectroscopy, this is also very important to your exam point of view. Here we are going to discuss about the theories, modes of vibrational, molecular vibrational, sample handling, instrumentation of dispersive and Fourier transfer infrared (FT) uh, FT IR spectroscopy. We are discussing about the instrumentation, and IR instrumentation we are going to discuss. And the important questions are asked, important questions and the important topics you have to, like, for sure you have to read are: the first one is the modes of vibrational molecular vibrational, sample handling, and instrumentation of FTIR. These are the very important topics, and the important questions asked previously in this topic, we can just refer it. You can see they were asked mainly about the modes of vibrationals. This is very important, and the working of the FTIR, and almost the questions are repeated, and the principle of IR. These are the questions asked, and we will continue with the first, the theory. Hello guys, myself Shiva. I'm also pursuing masters in pharmaceutics, uh, and I'm studying in Belgavi, Karnataka. I think so. You people know the state of Karnataka. I'm from Karnataka, and guys, it's very hard to prepare the notes which I have to prepare and give to you. It's very hard, and it's taking too much time for me to refer the standard books and to write these notes. So I please wish that you like my video and comment and subscribe my video. It will motivate me and my work so that I can continually give you the notes. Thank you guys for watching the videos. Okay, we will continue with the class. We will continue the class. First, the IR spectral. What is the IR spectroscopy, and what is the uses of the IR spectroscopy? Mainly, the IR spectroscopy, it is an important technique which is used to determine the structures of both organic and inorganic compounds. IR spectroscopy is used to study the structures. The main function is it is used to find the structures, determine the structures. What are the, like, how the molecules or the atoms or the functional groups are arranged or present. Then by IR spectroscopy we can determine that structures. Mainly, first definition, introduction. IR spectroscopy or vibrational spectroscopy. It is also called as vibrational spectroscopy because the atoms and or the ions are vibrating at their location, so that after the absorption of IR radiation, the molecules or the ions vibrate, or the atoms vibrate, so that it is also called as vibrational spectroscopy. Is the study of absorption of infrared radiation which results in vibrational transition. As I said, the molecule when absorbed the IR radiation, it results in vibrational transitions. Okay, I think so I've understood the point, what is mean by the IR radiation, IR spectroscopy, and the uses of IR spectroscopy. Then it lies between visible and microwave region. Means it, the range in EMR, electromagnetic radiation, it lies between the visible and microwave. It ranges from 0.8 to 1000 meter. Okay. Atoms of in the molecule do not. Okay, wait on. Guys, you tell me if the flash is needed or the flash is not required. You just tell me in the comments so that I can give you like better notes in the next video. Better notes where you can see it easily. Tell me if it's better or this is better. I think this is better. Tell me in the comments, guys. Let's continue. Atoms in the molecule do not remain in a fixed position but vibrate about their mean position on absorption of IR transitions from the ground vibrational level to the excited level gives rise to closed peak absorption spectra. Here it is the process of IR spectroscopy is given. See, understand this easy point. See, when the atoms in the molecule do not remain in the fixed position, they do not remain in the fixed position means they are moving above the plane, below the plane, they are moving away from the nucleus or coming towards the nucleus. These are all the possibilities occurring after the absorption of IR radiation. Okay, after the absorption of radiation, the atoms or the nucleus are moving away from the nucleus or coming closer to the nucleus, are moving above the plane or the below the plane. These are all the possibilities occurring after the IR radiation, IR transitions from the ground vibrational level to the excited vibrational level, which gives rise to close peak value. After the vibrational transition, as they are vibrating, peaks are formed. Peaked vibration spectrum is formed. This is used to identify the compound. Next, these are the regions near IR region, mid IR region, and far IR region. These are the different types of regions. You can just see. Next, we are going through the theory of the principle involved in IR spectroscopy. The study of interactions of electromagnetic radiation with vibrational and rotational references within a molecular structure is termed as IR spectroscopy. See, I already said that the interaction of electromagnetic radiation with vibrational and rotational references within a molecular structure is termed as IR radiation. As I said, when the IR radiation falls on the molecule undergoes vibrational rotational transition. These vibrational rotational transitions are studied under IR spectroscopy. I think so you have got the point. When the energy in the form of infrared is applied, then it causes the vibrations between the atoms of the molecule. As I said, when the IR radiation falls on the atoms of the molecule undergoes vibrations. When the frequency of IR radiation is equals to the natural frequency of vibration, the molecule absorbs IR radiation and a peak is absorbed. See, natural frequency means every molecule, every ion or every functional group has an frequency where the IR radiation is absorbed. Remaining IR radiation is transmitted. See, if example I will just give you in the next line. Firstly, understand this sentence. Next, you will clearly understand when I give you the example, but you understand this sentence. When the natural frequency of IR radiation is equal to when the frequency of IR radiation is equal to natural frequency, then the molecule absorbs the IR radiation. See, there is mainly like there is mainly one frequency where the molecule absorbs the radiation. It is a frequency where molecule absorbs radiation. If the IR radiation matches this frequency of the natural frequency, when the IR radiation matches the natural frequency, then the molecule absorbs the radiation and the peak is absorbed. This is the sentence explained in here. When the frequency of IR radiation is equal to the natural frequency, IR radiation is equal to natural frequency of the molecule. The molecule absorbs the IR radiation and the peak is absorbed. When these two are equal, then the molecule absorbs IR radiation and the peak is absorbed. I think so I have understood this sentence. Every bond portion of a molecule or functional group requires different frequency of absorption. As I already said, every molecule, every bond, every functional group requires different frequency for absorption. Here you can understand in a better way by this example. In HCl molecule, the natural frequency is 2819 centimeter inverse. If the IR radiation of this frequency, if the IR radiation of this frequency falls on the HCl molecule, the IR radiation is absorbed, whereas remaining is transmitted. I said if the IR radiation of this frequency falls on the HCl molecule, the IR radiation is absorbed, whereas remaining is transmitted. By this diagram you can understand. See, this is the absorption peak and this is the transmitted peak by the HCl molecule. The amount of light radiation is observed at 2889 centimeter inverse, 2889, and the remaining is remaining light is transmitted. I think so I've understood the principle and the theory involved in IR spectroscopy. When a chemical sample is exposed to the action of IR light, it can observe specific frequencies and allow the rest to pass through it, transmitted light. That's the basic concept of the IR radiation. I think so you have understood. If you have not understood any part of the line, you can just comment it. I will explain in the next video. Next, the very important topic in this concept, fundamental modes of vibration in polyatomic molecule. See, the molecule atom are not tightly held. I already said the molecules are not tightly held, means they are not tightly held as this pencil. They are held like the springs. They are held like the springs. You can see these springs. They can move, they can stretch, they can be like stagnant, and they can bend, they can move above the plane, below the plane. These are the possibilities after the IR absorption. Next, the molecules are not tightly held. The molecules appears to be consisting of different sized balls. See, atoms are tied with the strings tied with the strings. They are tied with the strings. Okay, chemical bond of various strengths. On passing IR light through the sample, the vibrational rotational energies of the molecule increases. As I said, when the molecule or the atom, example, this is the atom. If the IR radiation falls on the atom, the vibrational and vibrational rotational frequencies increases due to the IR absorption. Okay, there are mainly two types of vibrations. One is stretching vibration and one is bending vibration. I'll explain you in an easy understandable language. You'll never forget it. Okay, firstly, symmetric. I'll just explain you and then I'll show the the diagrams of it. Symmetric is nothing but the atoms, if the nucleus is present here, the two atoms are moving away from the nucleus, or two atoms are coming towards the nucleus. This is the symmetric means the both atoms are moving away from the nucleus, are coming towards the nucleus. Then asymmetric vibrations means if the nucleus, this is the nucleus, it contains two atoms. One atom is moving away from the nucleus and other atom is moving towards the nucleus. Okay, I think so I've understood. See, the stretching vibration in this type, the distance between two adjacent atoms increasing or decreasing, however keeping the atom in the same bond axis. See, the angle or axis bit is same, but the increase in the distance from the nucleus are occurring, or it may be increasing or decreasing occurs, that's it. But the bond axis is same bond axis. First one is symmetric. As already said, the nucleus is moving away, two atoms are moving away from the nucleus, or two atoms are moving close to the nucleus, increasing or decreasing in the bond length. Okay, next symmetric. See, symmetric, one atom approaches towards the center while other departs from it. See, one atom is coming towards the nucleus and other one is departing from the nucleus. I'll just show you the example by a simple instrument. I have two springs of the stand. I'll explain you. See, in okay, see, this pencil is the nucleus. In this is the pencil is the nucleus, and in what in firstly the symmetric. In symmetric, what is happening, right? This is the two nucleus. You think this is the two circles are two nucleus. The two nucleus are moving away from the nucleus. Wait, I'll show you a better technique. I have better technique to show that. 1 minute, guys. Be worth it. Huh. And I'll just move the camera to the upper part. You can see clearly. Huh. See, in the symmetric, what is happening, right? This is the pencil is the nucleus, and these pens are atoms. In symmetric, the atoms are moving away from the nucleus. They are moving away from the nucleus at the equal distance, or away from the nucleus or towards the nucleus, away from the nucleus or towards the nucleus. Okay. In asymmetric, what is happening, right? One atom is moving away from the nucleus, whereas other is coming closer to the nucleus. This is moving away from the nucleus, and the other atom is coming closer to the nucleus. That is asymmetric. And symmetric, both atoms are mingled together. They are moving away from the nucleus or the towards the nucleus. This is happening asymmetric and symmetric. That is the main difference. I think so. I have understood the concept behind the symmetric and asymmetric, and this is very important, so that I have like just made an using these tools I can explain you, because it can betterly understand and it will be in your mind. Next, bending or deformation or vibration. These they involve movement of atoms which are attached to a common center atom, such that there is change in bond axis and bond angle of each individual atom without changing in the bond length. See what is happening, right? In here, the bond axis and the bond angle is same, but a change in bond, sorry, my mistake. There is change in bond axis and bond length, but stay same in bond length, but there is no change in bond length. In the stretching vibrations, what is happening? The bond is stretched and there is no change in the bond axis and bond angle. There are two types. Let me adjust the camera. Mainly there are two types. There are mainly four types. This is scissoring. Scissoring is nothing but, I'll just show you the diagram of it. See, scissoring is nothing but, if the pencil is the nucleus, the atoms are moving towards each other. This is scissoring. So it is called as scissoring. They are moving towards each other. Okay, this is scissoring. That's why the name is scissoring. Next, rocking. Rocking is nothing but the atoms are maintained at equal distance and they are moving in equal distance. Equal distance is they are moving clockwise or anti-clockwise, like this. Okay, the bond angle is not changed. The axis is not changed, but here the bond length is not changed, as they are moving in the same direction, this way or this way, so that it is called as rocking. Okay, scissoring is nothing but the two atoms are coming closer to each other, like this. Scissoring. Okay, I think so. I have understood scissoring and rocking. Rocking means they are moving in a same direction, like this way or this way. They are moving in same directions. Next, wagging. Wagging is nothing but, okay, let me adjust the camera. Wagging is the one in this type. In this type, two atoms move up or down the plane with respect to the center. See, the atoms move above the plane or below the plane, and Twisting is nothing but one is moving above and one is moving below. I'll just show you the diagram for better understanding, guys. It's not that for you to understand, because at the first time I have not understood, but later on, after finding the examples in the internet, then I have understood how the atoms really fall. See, this is the example, this is the nucleus. In wagging, what is happening, right? The atoms are moving above the plane. Like these are the atoms, they are moving above the plane, like this, above the plane, okay? And or below the plane, above the plane, or they are moving below the plane, like below the plane. They're moving above the plane or below the plane. Two possible outcomes. In twisting, what is happening, right? One moves above the plane, whereas other moves the below the plane. This is what happening below the plane. This is what happening in the twisting. I think so I've understood. You can just see the diagram, the technique one more time, you can better understand. See, in wagging, what is happening? The two atoms are moving upward. Plus means above the plane. Minus means below the plane. Or the twisting means one is moving above and the other is below the plane. I think so. For today's class, it's enough. Tomorrow we'll discuss about the instrumentation involved in IR. Firstly, you take the today's class notes. See. Guys, if you have not understood, just comment me so that I can just explain you in a better way. These are the previous questions, previous year questions asked. You can see these are the notes. You can just pause the video and write down the details. For now, I'll just provide the notes, but still I have not reached that level to provide an link through the website, but for surely I will give the notes later on. The principle. Next, the example of the HCl. Next, the types of modes of molecular vibrations. Next, the last one, symmetric. Next, bending. Next, scissoring and rocking. Wagging and twisting. Thank you guys for watching today's video. I think so you have liked the video. Maybe if you don't like also, to just comment it. I will just improve myself. Thank you guys. See you in the next video. Bye.